Okay, so I gave you a promise that I want to show you a capacitor. We have different types of capacitors of different sizes of the capacitor. This is electrolytic capacitor, right? So when you say that a capacitor is electrolytic capacitor, it has only two terminals. We call it a simple electronic components or electric components. This is positive terminal, the longer, and this is the negative terminal. Also, we have ceramic capacitors. So this is the ceramic capacitor. So this one is store charge. This one is performing another activity, right? So that's why this is large in size. So while this one is, you see, so it has also two pins, but no negative or positive because it's not the, this is the electrolytic capacitor. So electrolytic means we have positive terminal and negative terminal. But this is non-electrolytic capacitor. We call it ceramic capacitor. That's why we don't have a longer tail. It means a longer terminal and the short terminal, right? So you have to enjoy this one. These are the stuff that we use to enjoy them in electronics. Okay, we know that some of the students who are watching this, they are lovers of electrical engineering or electronics. You're welcome again. So we prepare another special program for you, and we are selling these electronics components with a cheap costing, so you can have at your home, and then you can see the beauty of electricity or electronics without even going to the college. Okay, so that's all. I will tell you a lot when we'll be reaching the last subtopic. You have to stay connected or to stay tuned. But again, so you have another capacitor. This is another capacitor. Yes, this is another capacitor, because I have to show you. This is another capacitor, right? And then I will show you a resistor, because you know myself also I studied resistor during my advanced education. I saw the resistor is a very big guy, very big components. But when I will show you, you'll get surprised. This is another capacitor. It's an electrolytic capacitor, but small in size. Even the voltage you find is this also is kind of paper capacitor. So it's a capacitor also, but this is non-electrolytic capacitor. That's why it has not. It has equal terminals. Okay, that's the beauty of physics that we have to enjoy for the rest of our life, right? No, please close those boxes and send them there. Okay, so now we know the importance of the importance of electrostatics. I want to take you into another route of electric charge. So I want now, because we say that electrostatic is a study of electric charges at rest. So we want to understand what are those electric charge. Okay? So we say that I would like to teach you a small subtopic called the electric charges. Electric charges. So electric charge, say with me. Say electric charge. Okay? Say electric charge. Electric charge. So we have a question. The question is, what is electric charge? So what is electric charge? Okay, what's electric charge? Electric charge, okay, ask yourself, it's not a new term. You learned during your O-level studies about electric charge. But let me remind you. So we define electric charge as is a physical property. Okay, is a physical property. So this is the physical property of matter. The physical property of matter, okay, that causes it to experience. That causes it to experience a force. Okay, to experience a force when it is placed when that charge, electric charge is placed, it is placed in electromagnetic field. In electromagnetic field. Okay? So this is one of the definitions. I want to give you two because it's the fundamental concept. So it's a physical property. To start, electric charge is a physical property of matter that cause it to experience a force when it is placed in the electromagnetic field. So this is the physical property of matter. So it means that the matters are electric charge, the meaning. So it's a property it's a physical property of matter. And when those matters are placed in the electromagnetic force or electromagnetic field, they experience a force. Okay? And we are going to study about that force. Or some of the resources define that the electric charge are the particle which carrying either positive or negative electricity. Electric charges are the particle which are carrying either positive or negative electricity. So you have two types of electricity. Positive or negative electricity. Okay? So positive or negative electricity. So examples of charges of electric charge. Examples of electric charge are electrons and the protons. Again, we have to teach you about types of electric charge. We have two types of electric charge. Two types of electric charge. So we say that there are two types of electric charges that are: one, positive electric charge, and the second one, we have also negative electric charge. Okay? So the question is, what is positive electric charge and what is negative electric charge? Okay? So the question, what is positive electric charge? Positive electric charge. Positive electric charge. So positive electric charge, we say that the charge is a charge that carries positive electricity. So you have negative and the positive electricity. So example of the positive charges are what? Protons. And these positive charges, we say that are the atoms which have more number or a large number of protons compared to electrons. Because protons, remember, this is positive charge. So for example, if you have an atom X and then you find that here we have, let's say, the number for electrons or number of the nucleus, we say that for support that number of neutrons, means that for this element, number of neutrons is greater than number of electrons. Then for that case, that atom will allow only positive electricity to flow through it. Okay? Then another question, what is negative electric charge? What is negative electric charge? Okay? So negative electric charge, we say that the electric charge, okay, which carries positive, which is carries negative electricity, which is carries what? Negative electricity. Negative electricity. So it's electric charge which carries negative electricity. Okay? The example of this is electron. Electrons always carries negative electricity because electrons is negatively charged. So that's why we say that it carries what? Negative electricity. So negative electricity. Then again we say that what is SI unity of electric charge? What is SI unity of electric charge? So SI unity of electric charge, SI unit of electric charge is Coulomb. Say Coulomb. Coulomb. So the symbol is capital C. Coulomb. So this is the name of the physicist who did a lot of experiment in electrostatic. So again, we say again from the fundamental electrostatic or static electricity, we say that the charge which is Q, because we are going to start all about charges. That's why I'm introducing it slowly into your mind. The charge Q, we say that the charge Q, okay, of one electron. Of one electron. This is 1.6 exponent negative 19 Coulomb. Right? So we say that that's why that is a quantity of charge of electrons. Or we say even if by using a scientific calculator, you can find that the value of E, mean that this is 1.6 exponent negative 19 Coulomb. So that's the relationship of what? Number or quantity of charge. Right? So it's a quantity of charge. So we say that the charge on one electrons is that one. So for electrons, it's negative because it is electron. As in computation, don't use this negative sign, right? Yeah, so we have to understand that the charge of one electron, is negative 1.6 exponent 19 Coulomb. Okay? So bear that in mind. So now we have another vocabulary. And this vocabulary, possibly forgot it, but we made during our O-level education. Made a mistake in this, so it is Coulomb. Okay? Coulomb. So you have a vocabulary that we call the Coulomb. Say Coulomb. 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 Say Coulomb. So the fundamental question is, what is Coulomb? What is Coulomb? The fundamental question. What is Coulomb? Take a moment and think about Coulomb. What is Coulomb? You can say Coulomb is a unit of electric charge. We are going to sing about Coulomb and about electric charge. I think that for possibly 3/4 of electrostatic. So there are two definitions of Coulomb which I want to teach you. The first one, we say that Coulomb is that charge. So Coulomb, that charge, which when it is placed in Coulomb, is a charge. Okay, so this is the charge which when it has been placed in, okay, it has been placed in 1 meter apart, right? 1 meter apart. This is not a clear definition. I think there are some missing words. So you can discard it. So write this one. Coulomb, our best friend, names of the physicists. Coulomb is the quantity, okay? Coulomb is the quantity of the charge. Quantity of the charge flowing. Quantity of the charge flowing through a section. Through a section. Through a section of conductor. Of a conductor producing a current of 1 ampere. Producing a current of 1 ampere in 1 second. In 1 second. So that's the simple definition. Coulomb is a quantity of what? Is a quantity of the charge flowing through a section of a conductor, right? And then when it is flowing, it's producing a current of 1 ampere in 1 second. Let me explain what does it mean. If you recall the fundamental electrostatic, concept that you've been learned, fundamental electrostatic. Okay, fundamental electrostatic. If you recall the fundamental electrostatic, we told you that the quantity of charge, which is Q, this is given as product of electric current and the time. Right? This is the first equation, if you do remember. So that's why that we say that, for instance, by using this expression before I go to the another one, say 1 Coulomb. This one is equal to 1 ampere multiplied by what? 1 second. That's what it has been mentioned in this formula. So you say that Coulomb is the quantity of the charge flowing through a section of the conductor producing a current of 1 ampere. So suppose that this is the conductor. You have a conductor from point A to point B, right? And then 1 Coulomb, so a Coulomb is flowing, or a quantity of charge is flowing, passing at this point C, okay? It's flowing. And then when it has been flowing from point A to point B, that Coulomb produces a current of only 1 ampere in 1 second. produces 1 ampere in 1 second when it has been flowing through the conductor. That's why I told you that from this fundamental formula, you see the 1 coulomb is a product of 1 ampere times 1 second. So in other words, it means that coulomb, we can say that it's ampere second, in other words. But this is just for the matter of understanding. Don't write this one as a unit of 40 of electric charge, just for the matter of understanding, and especially for you to recall quickly about definitions of coulomb. Okay, so you're allowed to look for other definitions of coulomb. Right now, we like just to think a little bit of mathematically. We say that, or we learn that quantity of charge is equal to the product of current times time. Suppose that is the first equation. Also, during the fundamental electrostatic, which is called static electricity in O level, we learn that quantity of charge is equal to the number of electrons times electronic charge of electrons, right? Okay, so did you learn this stuff? No. So here then for the first time? Yeah. Sure. Okay. So if you have, I saw that you learned during your O level educations. Anyway, so we have quantity of charge is a product of electric current that flows through the conductor and time, in a particular time. And then quantity of charge is equal to number of electrons times electronic charge, which is 1.26 for negative 19 coulomb. But I believe that this is not new. You heard that once, right? And that's the unit of quantity of charge, you know that is coulomb. Good. So, okay, so as to accept this, okay, so we say that we will even learn this stuff in current electricity. So this is the quantity of charge, because remember, 3/4 of electrostatic is all about charges and charges and charges. We are going to sing about positive charge, negative charge, positive charge, negative charge. So you have to adapt it from now. So it means equation 1 and equation 2 are equal, right? So if they are equal, we say that electric current times time is equal to number of electrons times electronic charge. So what do you say there? Fine. So you can say that, okay, now you can deduce an expression there. It's a very interesting expression. So you can say that, okay, we say that now, to know the number of electrons that has passed this through certain sections of the conductor, we divide by time first. And then we have current is equal to it, number of electrons times electronic charge over time. And then we divide by what? Electric charge, right? So this one and this one will cancel. So you find that current of electronic charge, this is equal to number of electrons flowing passes through a certain section of the conductor, and this is very important expression for your life. Okay, again we say that we have quantity of charge. So we have 2 types of charge. We have positive charge and we have negative charge. So in physics, the positive charge we use right like this one. So we say that in the positive charge, we write like, I think that this positive sign is written whether it's suffix or prefix. Let me look. Let me take a look, because I want to give you true information. Yes, I remembered. So this is written as positive, and this is written as negative. If we use lower cases, this is positive Q, and the other is called negative Q. Right? So whenever you see positive Q, it means that the positive charge. Whenever you see the negative Q, that is what? Negative charge. The SI unit of quantity of charge, we say it is what? Coulomb. But we say that there are other units of 40 of quantity of charge, okay, that are, the first one we have mil-coulomb, which is this one, mil-coulomb, okay, which actually that it does not exist. but we have also microcoulomb, say microcoulomb, which is written like this one. We will use this in many cases. But also we have another unit we call the nanocoulomb. I have to introduce to you because you will see them often. Nanocoulomb. So it is NC, NF. Later on, so you have nanofaraday, microfaraday, millifarade, Faraday itself, which is equivalent to coulomb. And then the other ones, we can have something called the picocoulomb, if they exist. Just giving you in general. Picocoulomb. So 1 coulomb is equal to 1,000 coulomb. And 1 coulomb is equal to that's 1, so okay, is equal to 1 exponent 60 microcoulomb. 1 coulomb is equal to 1 exponent 9 nanocoulomb. Right? So you have to be familiar with this unit because in some of the questions you might not be given the quantity of charge in terms of coulomb. You should know the conversion between them. And then we say that again we say 1 coulomb is equal to 1 exponent 12 picocoulomb. Right? Picocoulombs. So again, we have a term known as conductors. So what are the conductors? What are the conductors? So conductors are the materials which have the free electrons on the surface of metals. So conductors, say conductors. So what are the conductors? So conductors are the materials which contains free electrons. Are the materials which contains free electrons. Contain free electrons in their valence shell. Valence shells that allow or that carries the electricity through the conductor. Then we have insulators. What are the insulators? Say insulators. What are the insulators? So these are materials which do not contain, so say that these are the materials. So examples of conductors are what? Copper. Then has a material that is a good conductor of electricity. Iron, and that one, human being, So this is said that the insulators are the materials in which these are the materials in which its valence electrons are strongly held by the nucleus. So, no electricity conduction. So give me examples of insulators. Examples of insulators are, the first one is plastic, second one is nylon, third one is wood, etc., etc. So those are non-conductors. Does a glass conduct electricity? Or we don't know? Then we have another important knowledge in introduction, which we call the electrophorus. Electrophorus. Say electrophorus. So you heard that to it. What's electrophorus? So that's the question that we have on the stage. What is electrophorus? Tie on the piece of paper to define and then come back to the lecture. What is electrophorus? This is the device it's a device which produces what? Produces charge by using electrostatic induction. By using electrostatic induction. Okay? That's the meaning of 40. Electrophorus. So then now, let me leave homework 1. Or you can go to homework 2 because it's session 2. In homework 2, we say that this one. Briefly explain. I believe that you are still doing my homework and you are going to submit soon. Only 2 that are submitted. So, briefly explain the properties of the electrons. So go and look properties of electrons, because here we are going to study it as a current carrying conductor. So briefly explain the properties of 40 of electrons. And even atomic physics, you will touch a little bit about those properties of 40, properties of electrons. So this is the end of session 2. Join me tomorrow. I would like in the next session, which will be session 03 or session 3, I'm going to teach you about laws of electrostatic. We are going to do a lot of derivations, and even possible that you can have a session for the word problem, for the problem solving. Don't think that electrostatic is a kind of we call them just a continuing story. No. Soon we are going to turn to stuff of having mathematical questions, having questions in whatever, and so forth. So this is just introduction. So I think that whether from session 3 or session 4, you are going to see now, because we can have even an entire video of just what problems are we going to solve today. So I thank God who have been with me from preparations and even during this time of presentation. And I thank you also who joined me. May God bless you abundantly for what you've done, by the way. And then I would like to invite you into the next session, that will be session 3 of the introductions of 40. Of that one, okay? The introductions of electrostatics. So I'm expecting to meet you there, and expecting that to take you from present point to another point. May God bless you abundantly. Please let us meet inside the lecture of session 03, and then so we'll be meeting frequently until that you succeed in life. So don't forget to share, subscribe to our YouTube channels, share the contents, challenge yourself, challenge other students. So it's not a time for you just to waste it for nothing. You can do something. So, okay, may God bless you. It's my responsibility to pray for you. I'll be praying for you, regardless of what the distance is, not distance in the spiritual. And also, I insist you also to pray for me so that I can accomplish this assignment successfully. So, thank you very much. See you in the next session.